Okay, today is all about block cipher modes of operation. So quick recap of what we talked about last time. We saw our very first encryption scheme, namely the one-time pad. And remember, in the symmetric encryption assumptions, we said Alice and Bob share a secret key that no one else knows. Encryption was bitwise XOR. Decryption was also bitwise XOR. If we use a different key every single time, this scheme is secure, but using a different key every single time is impractical. So that brought us to the next idea, which was a block cipher. And a block cipher takes in a k-bit key and an m-bit plaintext and outputs an m-bit ciphertext. And I think of it like k tells me which of the mappings of plaintext to ciphertext that I want. So I have all these different mappings of plaintext to ciphertext, one per key. And then once I choose one, that gives me a mapping of all the plaintext to ciphertexts for that particular key. And to encrypt, I just map the plaintext to the ciphertext. And to decrypt, I map the ciphertext back to the plaintext. For this to be correct, those arrows that you draw have to form a bijection. Each plaintext should correspond to exactly one ciphertext. And we said that a block cipher is defined to be secure if it looks like a random permutation. So if I give an attacker a permutation where all the arrows are drawn at random, and I give them a permutation where the arrows were run through the block cipher code with a particular key that's unknown to the attacker doesn't know which one came from the block cipher and which one was drawn at random. That's how you know if a block cipher is secure. That's the definition that we used. We said that it's relatively efficient. It's lots of XORs and bit shifting. Computers like to do those. The modern standard is something called AES. That's the actual code that you run. But we couldn't stop here because of two major problems. One being that the block cipher is not IND-CPA secure. It doesn't match that particular definition of confidentiality because it's deterministic. And it's limited to encrypting messages that are exactly m bits long. So today we're going to build something even better that hopefully solves those two issues.